All right, let's start today's lecture. So here's today's outline. We will go through some announcements first, and then we will go through a roadmap of what will be covered in the next few weeks. And then we will have a quick recap of the basics about Python. And then we will learn a Python module that is used to interact with Postgres. So the first announcement is about assignment 2. So the specifications will be released later this week, and the due date is to be determined. But we will make sure that you will be given more than 2 weeks for finishing your assignment 2. And Dylan and I are still discussing about which database to be used, but definitely it will be an interesting one. And this assignment is for you to practice how to use Python to interact with Postgres. And so you will be using Python for this assignment. And please try to do the assignments earlier and ask questions on the forums earlier, because in the last 1 or 2 days before the due date of assignment 1, we received a lot of questions, and we can't answer everyone very well because there are just too many questions. So if you ask the questions earlier, there's a better chance for your question to be better answered. And yeah, there are staffs and some helpful peers on the forum to help you to answer your questions. And the setup guide is released earlier than the questions, so make sure you try to set things up earlier, because on the last day, a few hours before the deadline, we received some private threads about talking about some issues of setting up or connecting the database on VXDB2. So that's very bad, actually. You can't finish everything in the last few hours, and so try to set things up earlier. And the last thing here about assignments is you should use private posts to post your assignment code. So some students, they ask about the bugs or issues inside their code, but they just post the code to the forum without marking it as private. So every other student can see their code. This is bad, so try to use private posts if you really want to discuss your code with us. So that's about the assignments. The second announcement is about quiz. So in this week, we have quiz 4, and the due date is this Friday, so just do it. And the last announcement today is about help session. So the Thursday help session is overlapping with the lecture, and it is to be shifted to 11 a.m. to 1 p.m. on Thursday. But when it will be officially shifted we need to wait. So that's all about the announcements, and let's look at the roadmap. So today previously we have learned all about SQL. So we know how to write queries, how to write functions, triggers within the Postgres. And now, today, we are going to learn how to use programming languages to interact with these databases. So this is what we are going to learn today. And then we will learn more about some theoretical aspects. And lastly, we will also learn some transactions and concurrency controls of database systems, which is useful when multiple users are using the same database. And then we will wrap up by talking about the future of database, having a review of the course, and having a preview for the exam, and perhaps we will have a guest lecturer from the industry to tell you more about how they use database in practice. But on week 10, I will be traveling for conference, but I will prepare the lecture videos for you. And now let's jump into the main content today. So as I just mentioned, we will be using Python for this course. And I hope that this is a recap for you. So I hope that you are familiar with Python before taking this course even. So Python is a very popular programming language. It is very easy to learn to use, and it has a wide range of useful libraries. And today it is particularly useful because of the popularity of artificial intelligence, because there are a lot of AI libraries based on Python. And in this course, we assume that you know enough about Python basics, and I hope so, because the primary topic for this course is still database, not Python programming. And if you are not overly familiar with Python before, you don't need to worry. So there will be many coding examples about Python in this course, and there are many excellent online tutorials. For example, learnpython.org. So you can learn it very quickly. So we are going to learn how to use programming languages to interact with the database. But why do we choose Python as the programming language here? So the first reason is that Python is a very popular programming language. So according to a very new ranking, Python is the most popular programming language, and followed by C or C++. And this is kind of rated by some programmers in the community, and it is not just counting the amount of code on GitHub. And that's why C or C++ is ranked a little bit higher here, because they are very, very important for building the infrastructures, like the operating systems, like the actual code of Postgres are written in C or C++. But still, Python is the most important one here. And can you find SQL on this list, on this ranking? Yes, it is ranked the 7th in this March. So we are learning some very popular programming languages here, and they are both very, very useful. So the second reason here is why we choose Python is relatively easy to learn. So trust me, you don't want to use languages like Rust for this course. So Python is arguably the easiest one here. So that's why we use Python. And for me, I think Python is a good scripting language, and it is also a good language for building large systems. For example, you can write some shell scripts and for some utilities like batch renaming of files, or just manipulating some files in your operating system. So you can use shell script, but you can't use shell script for writing a large server. So that's what you can't do. And you can use C or C++ or Java to write a web server, but you can't use. Normally, you don't use them to write some basic utilities. And Python is like a jack of all trade. So you can write scripts with Python. You can also write complex systems with Python. And there are many famous frameworks built with Python. For example, for Django, I believe you may have heard about that before. So Python is an interpreted language. So do you know what's the difference between interpreter and a compiler. So C language is a compiled language in contrast. So what it does is the source code of C program will be compiled by a compiler into the machine code, which is executable by the CPU. And Python is not compiled. It's interpreted line by line via an interpreter, and this engine will execute the code. So that's the difference here. It's not directly executed on the CPU. And this is a detailed comparison about compiler and interpreters. And in general, compiled languages are faster than interpreted language, but they are less flexible. And examples of compiled languages are C, C++, or C#. And the interpreted languages are Python, Ruby, Perl, or PHP. So do you know if Java a compiled language or interpreted language? Java is not dependent on the CPU. So C code is dependent on the CPU. If you compile the C code for an ARM CPU, you can't use it on your Intel CPU computers. And if you compile it for Intel CPUs, you can't use it for ARMs. But Java is not. You can use your Java code everywhere. But is Java a compiled language or interpreted language? Actually, Java is a compiled language because although it is not dependent on CPUs, it is compiled into bytecodes running on JVMs. So Java is compiled. It is a lot faster than Python. And if you are not very familiar, if you are kind of confused by the concepts of interpreters and compilers, here's a good example. So you can just consider the compilers or interpreters as human translators or human interpreters. So for human translators, it takes the entire chunk of text or the entire chunk of information and translate it into another language as a whole. And for interpreters, they just hear the stream of voices and try to translate that voice or that speech into another language. So it's kind of it's just like streaming or translating the entire thing as a whole. So that's the difference here. So for execution of Python, so you can either use an interactive interface like PSQL. You can use Python interactively, or you can run the programs that are stored in files. So this is how you execute Python functions or Python programs. So now let's jump into the details of Python language. So like C language, Python program consists of expressions, statements, control structures, function definitions, imports, and all the similar things. And the key characteristic about the syntax of Python is it uses indentation to indicate code nesting. So it doesn't use brackets to indicate the nesting structures of code, and it doesn't use semicolon to mark the end of a line. So it doesn't support. It does support multi-line code, but you need to concatenate the code together. So this is the key thing about the syntax. The key characteristic of Python's syntax. And you may think, okay, it's easier to write Python code because you don't need to worry about the curly brackets. You don't need to wrap everything into brackets. But you may get a lot of errors if you're not careful about the indentation. And you can't mix different types of indentations. You can't mix tabs with spaces. You can use 4 space, you can use 2 space for your indentation, but or you can use tab, but you can't mix them together. And you don't need to, normally you don't need to worry about that unless you are using Nano or just your text pad to edit your code, because most of the modern IDEs, they are handling the conversion of indentations for you. For example, they will, if you open a Python code within PyCharm, for example, it will tell you, mixing with a mixture of tabs and spaces, it will tell you, it will warn you that your code has a mixture of tabs and spaces, and it will automatically convert everything into tabs or spaces. So you don't need to worry about this if you are using an advanced IDE. And for comments in Python, they are indicated by the symbol of hashtag. So a hashtag means a single line of comment. And here are the data types and constants. So they are actually very similar to C data types, but there are some unique data types for Python. For example, dictionaries. So you can consider dictionary as it is like a collection of key value pairs. So that's dictionary. And assignment in Python, so value assignment is via the equal sign, and it is used in many other programming languages as well. So let's quickly go through an example of some basic Python code. So these are some variables declared in Python code. As you can see, we have declared a string. So we don't need to tell which type of, we don't need to tell the type of the variable here in Python, unlike in C, unlike in Java, because Python is interpreted. It doesn't enforce the type of variables unless you specify that type. I think this type enforcement is introduced in Python 3.8 onwards, or maybe 3.10. So you can specify the type of variable when you declare it for the ease of for the readability of the code, because when other people read your code, they will know the type of that variable, but it doesn't affect the semantic of that code. So this is about the types in Python. And here are some basics about how do we print out things in Python. So you can see that we can easily concatenate strings with the plus sign, and we can also use the format strings. And this format string style is only available for Python 3.8 onwards. So before Python 3.8, we need to use some other means to do format string. For example, we can use the dot format function to generate format strings. So that's all about how we print out things, and here are some examples of some basic mathematical notations. So this double multiply means to the power of. So this is to the power of 3 to the power of 3, and this is division. And this one is, I think, is to calculate the remainder. Let's see. Oh, it is calculation and calculate into integer. So this is, here are some basic mathematics operations. And here, let's have a quick look at some examples of function declarations in Python. So in Python, we can also, like many other programming languages, we can declare functions. And we don't need brackets to enclose the entire function. And here are two examples for writing a function to calculate the factorial of a number here. So we can either use an iteration to calculate factorials, or we can use a recursive function to do this. So and here this iteration function is working properly, but the recursive function is not. So can you quickly come up with how should we fix this recursive function? What should we return here? Yes, it should be n times factorial recursion n minus 1. And this will give us the correct answer. So this is how we do recursive, how we run, how we define and use Python functions. And it seems there's an error in the first one. It should be n plus 1. Okay, that's it. And just now we have covered the basic statements, the basic expressions, and data types in Python, and also the definition of functions. And now let's go through more syntaxes or usages of Python. And like in many other programming languages, we can import external modules within a Python file, and each module is a collection of definitions. It could be the definitions for functions, it could be definitions for variables or constants. So when you import a module, you are actually not only importing the functions, but also those constants and variables. So packages, for example, for PSY COPG2, which is the package we are going to learn today, is a collection of sub-packages and modules. So it's just like a library. So this is how we can import things in Python code. We can either use import, or we can use from import to import. If we just use import, we are actually importing the module itself. And if we use from import, we are actually importing a sub-module or a particular function or variable or constant. So this is how we can do importing in Python. And also, Python programs can take command line arguments or options via a variable called sys.argv. And we can we can have a try of this one here. So do you understand? Can you understand what will this little Python program do here? So it will actually print out whatever we give it from the command line. So this is what this small program will do. And if we run it with no command line arguments, you can see that nothing is printed out. And if we supply it with some options, for example, -a, -b, -f, it will print out all the arguments we have supplied to this small program through the command line. So you can actually use sys.argv to access whatever command line options given to the small Python program. However, this is not this is an easy way of doing things. But if you are writing a serious Python program that is maybe to be used by some other people, you would better use the argpath module to handle command line options or command line arguments. And this is a link to that module, but because we are not really learning Python today, so I'll just quickly go through this, and you can have a look at this document if you are interested. So, but of course, in this course, we don't need those complex things. You just need to know there are this thing. And now let's learn PSY COPG2. So that's the Python module you will be using for your assignment 2. So PSY COPG2 is a Python module that provides a method to connect to Postgres databases. And it also has a collection of DB-related exceptions, because as you are doing you have done your assignment 1, you must have encountered a lot of exceptions when you write your code, right? So actually, these exceptions are produced by the database, but they are not for Python. So this Python module will convert those exceptions into Python exceptions. So it is not only a collection of methods, it's also a collection of exceptions. And of course, it has a collection of type and object constructors. So those are specific to Postgres. In order to use this module in a Python program, you just need to import it. You just need to import this module. However, before you can import this module, you need to install it. And if you are familiar with Python, you will know this website called pypi.org. So it's a website hosting most of the Python modules which are available there. So you can find whatever modules you like on this website. And of course, it is also hosting the module we are going to learn. And you need to install this module first. And when you install modules, it's better to be installed in a virtual environment, because different libraries may depend on other libraries, and different libraries could depend on the same libraries of different versions. So if you are installing everything just without using the virtual environment, you will run into trouble. If you install a lot of libraries, you will have version conflicts for the dependencies. So that's why you should isolate the environments of Python dependencies or libraries using virtual environment in practice. But in this course, you don't need to worry about all these things. So these are just some best practices. And because this library has already been installed for you on your VXDB tool for Python 3, so let's have a quick look at this. So first, you need to log into your VXDB tool, and after that you just run wait. And but you don't need to run the server to test out your whether the installation of this library. But I'm starting the Postgres just to show you some basic usage of this library. And now we can come into the topic. Python 3. We are using Python 3 for this course. We are not using Python 2. And Python 2 is not installed on Linux on most of the systems by default now. So let's use Python 3, and we can import psy COPG2. And as you can see, it's not complaining that we are missing this module. So it means that it is there. It is already installed. And we can use it. We can actually use it. And one of the most basic commands here is to use the connect. And we will cover the detail of this command later. So for example, I have a DB called test DB, and then this is how I connect to this database. And then I can use this connection to give me a cursor. And this cursor is like a handle of accessing the database. Oh. Missed an R here. And we can use cursor to execute anything, so we can use cursor to execute any SQL commands like selection of tables or even creations of tables. So I have some tables here. So let's select from employee, but it's empty. So let's just have a look at the things here. So select from, oh, there's no employee. Current transaction is until end of. Oh, as you can see, we are actually already, although there's an error here, but we are already executing this command, and you can see the exception is converted into a Python exception here. So this is a relation does not exist, means the table is not there, and because I didn't type an E here, it should be employee table, and as you can see, this exception is converted into a Python exception, so we can handle this exception inside our Python code. So this is just a quick give you a quick feeling about what is PSY COPG2. And yeah, it's already there, so you can just use it like what I have done just now. And although we are learning PSY COPG2, and there's a third generation of this library, and it is available now. And the current version is 3.1. The design level differences are here in this link. There's a blog it's a blog by the author of this library. And why we are not using the newer version of this library is because that library is still under development. It could change in the future, and the last released version is in 2022. But it may still change in the future. But PSY COPG2, the second generation of library here, is relatively stable. So what you learn today won't be changed, at least in the next few years. And it is not getting outdated because this library is still actively maintained by the developers. And the last commit, I think, is from last month, a month ago. So it's still actively maintained, although there's a newer version of this library. So just to let you know. And this is the basic workflow of this module. So what we do is we write Python code using this library to connect to the database. And then we can send SQL queries or statements to the DBMS. And then we can collect results from the DBMS. So this is the basic workflow here. And before we go into the details of how to use this library, let's have a 10 minutes break. Sorry, I forgot to bring snacks today. Sorry about that. Let's have a 10 minutes break. You can try to play with the library and try to see if you can successfully import this library since you have brought your laptop here. You can try that. All right, let's start the second half today. So let's now learn how to use how to actually use this module to interact with Postgres. So the most basic function here or method here to be used is called connect. So this function will return a connect object to you, and this connect object is to hold a session of interacting with the database. So and if we can't connect, it will raise an exception here. And you may notice that this connect method only accepts one parameter, which is called DB connection string, and this string has some formats. So it is made up of a list of assignments, variable assignments, and here are the key components. So just now we have used the connect with database name. So we need to specify the name of the database we would like to connect to, and then we need the username and password, and also the host. So we may access a database that is on a remote computer through some host name or IP address, and we need to specify the port, and of course the database DBMS is listening to some port on the computer, and we need to specify the port. But in VXDB2, we just need to specify the DB name we would like to connect to. So everything else is by default. You just use the default value. So that's about connections. And here's an example of how to open and close a connection. So as you can see, since the connection, if the connection fails, it will return us an exception. So we can use try except to wrap the entire chunk of code, and then inside this code we can use connect to get the connect object, and we should every time after you have written the main logic of the code, it's a good practice to close this connection here to release the results held by this connection session. So this may not affect how your code works, but it is a good practice, because if you have too many connections to your database, it may cause you some trouble. So that's why we should use connection close. And here are some operations we could do with the connection object. So the first one is cursor. So we can use the cursor method to return us a new cursor, and this cursor is like a handle for performing queries or updates on database. So it is like a handle for sending statements to DBMS and for collecting results from the DBMS. So this is the function of the cursor, and we must create a cursor before we could actually perform DB operations. So this is the first one, and the second one, of course, is close. So it's a good practice to close connections after we have done with the main features. And commit is to commit changes to database since last commit. It means that if if we open a connection and we create a cursor, and then maybe we create some table, we update the columns of a table, it is not actually reflected in the database. If we modify something, we have to commit it to the database. So this is the commit function. And there are many other functions, and they are available here on this in the documents of the library. And actually you can also specify auto commit when you create the connection object. So there are many other operations, but here are the most frequently used ones. And just now we encountered a new concept here, which is called cursor. So database cursors are actually like pipelines to the database. So they are in charge of sending statements from the Python code to the DBMS, and they are in charge of collecting the results from the DBMS and present it to the Python code. So this is the basic functions of the cursor. Of course, since we can send SQL statements via a cursor, so it allows us to execute queries, perform updates, and change metadata through the statements we send. So cursors in this library are created from a database connection, and we can create multiple cursors using the same connection. We just invoke the cursor method multiple times to create multiple cursors, and each cursor is in charge of handling one database operation at a time. So just now, as I have shown you, I made a typo in the statement, and then if I want to reuse that cursor, it is stopped by the system. So each cursor actually handles one DB operation at a time. But cursors are not isolated, so each cursor can view other cursors' changes. So this is something you should keep in mind of. And this is the syntax for creating a cursor object. So it's quite straightforward. We don't need any arguments for this function. And here are some basic operations that we could use with a cursor. So the first one is we can execute any SQL statement with a cursor. So this function accepts two parameters. The first one is the basic SQL statement, and the second one are the values to be inserted into the statement. So it's like we can create a base statement, and we can modify that base statement with a list of values. So here are some examples. So for example, for the first one, the values parameter is optional here. So the first one, if we don't specify any values, we just specify a single statement, it is okay, it will run it. And if we want to modify the statement dynamically, we can actually supply some values to the statement here. Actually, as you can see, it is actually replaceable by a format string. So we can actually also we can always ignore the values here by just creating a format string made up of variables we want to supply to the statement. But it is this function is purposefully created to separate the values and SQL statements, because we need to convert data types from SQL to from the data type and syntax from SQL to Python. So if we want to build up our own string, it is likely that we may make some errors. But if we just use the values here, this library will help us to handle the conversion of different data types or syntax. We will see the conversion later. So this is why we separate statements and values, even though we can just use a format string to put everything into the statement. And as you may see, the conversion from statement plus values into one statement is handled by the library, and we don't know what is the final string or the final statement supplied to the database. And this is a function to tell us what will be supplied, what the actual statement generated by the library before sending it to the database. So this is useful for checking on whether the execute is doing what you want. So it's not, unlike execute, it's not sending the statement to the library. It's just printing out the actual statement we have. So this is the database. This is the Mogrify function here. And just now we have shown how do we send statements to the DBMS, and cursors can also help us to collect execution results from the DBMS, and it is done by the fetch functions. So why do I say fetch functions? It's because there are a set of functions that could be used for fetching data. So the first one is called fetch all. So it will collect all answers for a query and store it as a list of tuples. And we can use a for loop to iterate through the list of results here. So this is an example. So after we have done a selection with the cursor here, we can use fetch all to collect a list of the tuples returned by the database. So this is fetch all, and there's another fetch function called fetch one. So fetch one is used to get the next result for query, store that result in a tuple, in a single tuple. And what if we have a list of results? We can use the while loop here to iterate through the list of results. So as you can see, every time we can just fetch one, which is to get the next result returned by the database. And when we reach the last result, it will return as a null here. So it is the null value used in Python. So if we have reached the last item in the list, it will give us none. So this is fetch one. And there's another variation here, which is called fetch many. So fetch many accepts one parameter here, that is the number of tuples. So it will give us the next n tuples specified in the parameter for query. So it will give us multiple results here, and it stores these tuples into a list. And when there's no result left, it will return an empty list. So like fetch one, we can use a while loop to get the results, to fetch the results from a list of return values. So this is how we can use fetch many. As you can see here, the termination condition for this while loop is to check whether the result is an empty list. So whenever it comes to the end, it will return an empty list. So this is the function of fetch many. Just now we discussed why this library is designed to separate statements and values. Is because it tries to help us to convert data or syntax format from SQL to Python, from Python to SQL. And because there are some minor syntax differences between SQL and Python, for example, in Python we can use single quote or double quote to indicate strings, and we can use backslash for escaping. But for SQL, the string is different. The escaping method is also different. So if we build our own statement with format string, we may end up into some errors. But if we just use the statement plus values, it is automatically handled by the database, by the library. So we don't need to worry about the correctness here. So here are some basics about strings, and do take note that Python does support multi-line strings with triple double quote. So you can use multi-line strings to hold the statement, the SQL statement you would like to execute with the cursor. So this is something that could be helpful. And for tuples, in Python, tuples can contain multiple values of different types. So it is similar to composite tuple in Postgres. And tuple is written as a parenthesis and a list of values. And examples are here. So if we don't put the comma here, it is not a tuple. It is not recognized by Python as a tuple. And tuples are also, it's a bit different from SQL here, because it is a composite tuple. And as for invoking Postgres functions, there are two ways to invoke them. So do you still remember how to invoke a Postgres function? What is the statement to be used? Select. Yes, select. So the first approach here is very straightforward. We can just execute a select statement here to invoke that function. So with execute, we can execute anything. So you can do whatever you want through the Python interface. So the first type is select. And the second approach is specific to this library. It is called callproc. So we can use the callproc function to invoke Postgres functions. So this function accepts two parameters. The first one is the name of the function, which is supplied as a string. And the second one is a list of values which are used as the parameter for that Postgres function. So these two methods for invoking Postgres functions are essentially the same. And here are some tricks for using this library. So just now we have seen that we can use select statements in execute, but like what I have addressed, we can use any statement, SQL statement, with execute. We can update, we can delete, we can even modify metadata. We can create tables, we can drop tables, we can create views, and selection doesn't affect the actual content of the database, so we don't need to commit after we do selection. But if we want to really modify something, don't forget to commit the changes. And for the usage of fetch many, it can give us a list of next number of tuples, and we could use it to replace the limit keyword in Postgres in some context. And here, since as you can see, this module, this library, gives us the capability of mixing Python code and SQL, and sometimes the logic could be either implemented on the Python side or on the SQL side, like what we have seen on the last slide. We can use the fetch many to replace the usage of limit. So it could be done. So there are a lot of different types of logic that could be done either on Python side or on SQL side. So, but what is the best practice here to keep in mind? So how could we improve the overall performance? And the tip here is, for better performance, we should try to reduce the number of queries, because in the workflow we have shown you, the Python is sending and getting data from the DBMS, and if we repeat this sending and getting process for many times, it could be time consuming. So we should reduce the number of queries. So that's what you should keep in mind. So for example, we have two pieces of code here, and the first one is like this. So first we select X and Y from the table R, and then from what we have selected, we check it. We check the value against the values from another table. So this is the first implementation here. And the second implementation here is we join the table R and S first, and then on some conditions for here first, and then we select what we want from the result. So which one do you think is better here? The one on the left or the one on the right? is actually quite clear. The implementation on the right is better because we are doing much less queries. So in the code on the left-hand side, we are putting a query inside a for loop. So we are querying the database through the Python interface multiple times. And on the right-hand side, we only query the database once. So the overall performance of this piece of code is much better than the one on the left. So this is something you should keep in mind of. And that covers all about the Python interface for Postgres, and you will be using it for your assignment too. And as you can see, assignment 2 is set to be for you to practice using Python to interact with the database, but it is essentially still for you to practice how to write proper SQL statements. So that's all about today's content. And thank you for coming to today's lecture. Don't do that. But if you have any questions, you can ask me.